Hi, welcome back. Now in this video we will look at some of the statistical functions. Now the first one is min. This function returns the smallest number in a given set of values and it ignores logical values and text. The syntax is straightforward, is equal to min, then in parentheses the numbers which we want to check for or the numbers from which we want to identify the minimum value. Now over here I've got three values 3, 5, 3, and if I want to identify the minimum number I will just call up the function minimum and then pass on this range and it gives me the result as 3. Now 19a1, this gives me 1. It has ignored a text value. 8bc, it gives me the minimum value as 8. Minus 8.53 and zero point 0.5, it gives me the minimum value as minus 8.5. Moving on to the next one, which is max. It's opposite of minimum. It gives the largest value in a given set of values and ignores logical values and text. I will not be going through this particular formula over here. Average. This function returns the average value of the given numbers. It ignores text values and blank cells. The syntax is pretty straightforward, is equal to average and then in the parentheses the range of cells for which you want to calculate the average value. Now over here I've got number 1, number 2, number 3, and the first row has 3 blank and 5. This is giving me as 4 because it is ignoring the blank cell. 19a1, again it will just consider these two. 8bc, it will ignore these two and it's just giving 8 divided by 1, which is 8. And over here it is going to first sum all of them and then divide by 3, which is minus 1.6667. Moving on to the next one, which is small. This function returns the nth smallest number from the given set of values. Now the minimum function gives us the lowest value, but what if I don't want the lowest value? I want the second lowest value or the third lowest value. In that case, small or large functions can be used. Now small, my array or the range of cells and the nth small number from the list. Now this is my array or list of numbers. Let's say I want the smallest number. So the smallest number over here is minus 8.5. So as you can see, I've just done small. I've passed on the entire array from A18 to C21, and then D18 basically consists of the value 1, basically the smallest number which I'm trying to identify. So it is minus 8.5. Let's say I want to identify the fourth lowest value. So for that, it gives me the result as 1. So again, I'm passing on the entire array and then I'm passing on the value 4 as the fourth smallest number from the entire table. I've given you one exercise over here, so just go through it. It will help in better understanding this function. Large is exactly opposite of small, so I'm not going over here. Count. Now this function returns the count of number of cells which consist of numbers. The syntax is equal to count and then we are passing on the different cell locations. So for example, in this particular row, I want to count the number of numbers. I'm just using is equal to count and then I'm passing on this range. It gives me a result of 3. Over here, it gives me a result of 2 as a is not a numeric digit. Then 8 blank 20, again it gives me 2 because this is blank. Minus 8.5 blank b, it gives me 1 because this is the numeric digit over here. Countif. Now sum if, sum ifs, average, average if, average ifs, count if, count ifs, they're almost identical. And once you go through the sum if and sum ifs video after the VBA module, you'll be in a better position to understand countif, but I'll quickly give a brief description of this function over here. Now this function returns the count of number of cells which conserve numbers and meet a specific condition. So I've got my countif, range and my criteria, and this is that criteria which if it is met then only we want the function to count that particular cell. Now over here I've got 4 columns which consist of numbers. The fifth column, column E, it consists of the criteria which I want to check. So for the first example in row 18, I want to check or basically I want to count all the numbers which are greater than 1. So by just eyeballing them, I can identify that there are three numbers which are greater than 1 and the fourth one is equal to 1. So if I look at the function, it is equal to COUNTIF. I'm passing on this entire range A18 to D18, and then I'm passing on my criteria, which is that it should be greater than 1. The second one looks at value equal to 0. If you just do an eyeball, there is only one value which is equal to 0. It is ignoring the blank cell. And as you can see with the formula, we are passing on the entire range A19 to D19, where value is 0, it gives us 1. Let's move on to standard deviation. Now this particular function gives us a standard deviation of a given set of values. In terms of statistics, the lower the standard deviation, the better, as it implies that there is not much variance in the data and the population is more identical. Blank cells, text and error values are ignored. So standard deviation, and over here in the parentheses we are passing on the numbers. Now this is my range of numbers over here. If I want to calculate the standard deviation of them, I'm just doing is equal to stdev.s, because this is just a sample, and then A16 to D16 is the range of cells. So it's giving me a value of 13.07. If I look at 42, 40, 47, 47, the standard deviation is just 3.559. And if you compare all of these standard deviations, this is the lowest. And as you can see, if you compare these four numbers also, they are more or less near to each other. So that is why standard deviation is less. Variance is the square of standard deviation. So again, as with standard deviation, the lower the variance, the better. But it also depends upon what sort of analysis you are doing. Because if you're doing clustering, you would want the variance within a cluster to be less and variance between two clusters to be more. The syntax is equal to var.s, and then you're just passing on the numbers over here. And if you look at the last row over here, this has the least variance as compared to the upper numbers. Basically, the numbers are exactly the same as what we had for standard deviation. It's just squaring them. Let's look at the next function, which is correlation. Now, this particular function returns a correlation coefficient between two data sets or two arrays. Now, correlation usually lies between -1 and 1. If the correlation is negative, then it is termed as negative correlation. Otherwise, it is termed as positive correlation. If it is 0, then it is termed as that there is no correlation. Let's take an example of a positive correlation. Now, as a baby grows older, the baby's height or weight increases. So this tells us that there's a positive correlation because they both are increasing together. And if I look at a negative correlation example, let's say you've got your salary account. Now, as your expenses increase, the balance in your account reduces, which tells us basically when one is increasing, the other is reducing. So that is negative correlation. Let's look at the syntax is equal to correl, and array1 and array2, basically we're passing on the arrays between which we want to calculate the correlation. So this is my age and this is my weight. So as you can see, with the increase in age, the weight is also increasing. And if I use the correlation function on this particular array, it is giving me a correlation of 0.993, which is positive correlation. Let's look at median. This function returns number which is in the middle of all numbers in a data set. So is equal to median and then the list of numbers. So I've got this list of 20 odd numbers over here and I want to calculate the median, and the syntax is pretty simple, is equal to median, and then I'm just passing on the cell locations. So it gives me 84. Now let's see if we can calculate it manually. Just copy them over here, put a filter and then sort them. Now, as the definition states, it returns the number which is in the middle of all numbers in a data set. So I've got 21 observations over here. So the middle observation would be 11. The 11th observation should be my median: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 84. Now, lastly, we'll cover normal curve over here. And basically, we can calculate it using average and standard deviation functions. And now I've got this list of data over here, which is somewhere around uh, 4,700 observations, and these are all random numbers. Now, the first thing for me to calculate a normal curve would be to calculate z, which is x minus mu by sigma. So x is my observation, mu is the mean of all of these observations, and sigma is the standard deviation of all of these observations. So I've calculated the z value for all of them. For calculating mu, which is mean, and sigma, I've used the average function and I've used the standard deviation function, which we have just gone through. Now, once we have calculated z, we have calculated rounded z, which is using the round function. So we have used a round function for all of these values and we've rounded them off to 0. And then using a pivot table, the maximum value for round z is 4 and the minimum is -4. These are the number of data points across all of these. So this is how our normal curve looks like. So that is all we have on the function side. Now, if you have any queries around a specific function which you use in your day-to-day work or which you want to know more about, then just drop us a note. Thank you.